All right, what's good, Logan? Coming through with a second video. So after the first one, what I realized is that a lot of the students in first period still had a little bit of extra questions. So I wanted to address one more thing. So we're going to revise or revisit, radical inequalities today, or in the second video. What I want to make sure that we understand is that there's two types of problems. We got the square root type of problems, and then we got the cube root type of problem. This one right here, that's a square root type because it's got a square root. This one here is a cube root type. Now, the square root technique, what we're going to do is we're going to solve them first, and then we're going to check the radicand. So there's an extra step when solving the square root type of problems. But in the cube root type of problem, we're going to solve them, and then, yeah, that's right, you're done. As soon as you solve it, the cube root is finished. Now, the reason is that cube roots, these types of problems here, are allowed to be negative inside the cube root, also known as inside the radicand, or the radicand. In the square root type problem, however, you're not allowed to have negatives inside of it, so those are the ones that have the extra added step of checking the radicand. So if you have a problem that looks like number 4, the first thing we're going to do is get the radical by itself, dividing both sides of the equation by 6. So we divide the left and right side by 6. This gives us the square root of x minus 2 is less than 3. Then we're going to go ahead, now that the radical is isolated, we're going to square both sides of the equation. And this gives us x minus 2 is less than 9. So we have x minus 2 is less than 9. Adding 2 to both sides of the equation, we get that x has to be less than 11. So we know our solutions are all going to be x is less than 11. So it can be 10, 9, 8, 7. And if I ask students what they are, they'll go through that. But don't forget, this also includes negatives. So we'll go 7, 8, 6, 5, 4, 3, 2, 1, 0, -1, -2, -3. All of those are allowed under this solution right here. So what we need to do now is, since it's a square root type problem, we need to verify that the radicand can accept all these values. Now, the radicand has a limitation. The radicand in a square root is not allowed to be negative. That means it must be greater than or equal to 0. Now, that in turn is going to be a solution, or something we can solve, where we know that our values must be greater than or equal to 2. So while we got a solution of numbers less than 11, our radicand stipulates or restricts numbers that are not greater than 2. So our solutions must be greater than 2 because of the radicand. What this means is all of our solutions have to be less than 11, but they also have to be greater than 2. So we're going to write down our solution for this as all the values that are going to be between 2 and 11. So we're going to say all of our solutions have to be between 2 and 11. Now you'll notice that since the 11 has the not equal, but just the less than part to it, I've put a parentheses. And since the restriction says that it can equal 2, I've put the bracket. So remember, bracket means you can equal it, parentheses means you can't. If you wanted to write this in set notation, we would write it as all the values between 2 and 11, that's the x values, where 2 is less than or equal to x, and x is less than 11. So these two answers right here are your two solutions, or the two ways to write the same solution in different techniques. All right, let's swing over to problem number 5. Let's take a look at this one. Since the radical's by itself, we're going to go ahead and just cube both sides of the equation. So we cube the left side, also cubing the right side. What this is going to give us is 3x is less than or equal to 216. We're going to go ahead and divide both sides of our equation by 3. And this is going to give us x is less than or equal to 72. Now, we want to go ahead and check the radical. But because this is a cube root, the 3x has no limitation. 3x can be, well, pretty much all real numbers. So since x can be anything, then that means our answer of x less than or equal to 72 has no extra or added restrictions on it. So our answer are all the x values less than or equal to 72. Now, if you wanted to write this in set interval notation, then you have to think, well, what are the numbers that are less than 72? Well, that would mean 72 is the largest. And when you write interval notation, you put the larger number on the right side. The smaller number goes on the left. Now, since there is no limit to how small the number can get, we're going to say negative infinity. Now, infinity is always something that we can't attain, so we're going to put a parentheses on it. And since we can equal 72, we're going to go ahead and put a bracket on the 72 side. Our solution can either be written in set notation or in interval notation. Hopefully this helps things out. Once again, if this doesn't make sense, talk to me on Monday. You can even send me an email if you want, and I'll get back to you as soon as possible. See you guys later.